And welcome to the Daily Space Weather Show, coming at you with more 24-hour videos of the closest star, just bringing you the most comprehensive daily space weather in the known universe, and the most detailed solar imagery here from the Smash News Network, least busted name in news. That's 171 angstroms from SDO. You may see an awesome CME down there in the lower part of your screen. And by the way, if you haven't seen the video from yesterday, our space weather video, it's got a segment about being peer reviewed. Here are some close-ups of that CME that kicked off this morning. It was pretty good timing for our live stream, which was over 5 hours in length. We've had a decline in solar activity a little bit since yesterday, but some interesting features to cover nonetheless. We'll be speeding this video up a little bit, as we are already running a little bit late. Don't forget Sunspot 3576. It's still likely to produce large flares for another about 24 hours. So don't be surprised to see a large flare come from an area behind the limb back there. Also, we've got this sunspot trailing it that's starting to look like a goat or something. Check it out. There's a close-up of that. It looks like a galloping horse or something. It's like a flaming horse that just decided to jump right there. Tell me you don't see that. Looks like a flaming horse galloping across the sun. Or perhaps a goat. I don't know. Let us know what you think in the comments. Perhaps a skeletal goat. And there is the northern hemisphere. Look at the massive filaments up there. There is a lot of action to be had. And let's take a brief look at coronal holes here next. That's a 48-hour video, SDO 211 angstroms. The optimal wavelength for coronal hole viewing. Coronal holes are pretty light right now, no majorly well-defined ones. Taking a brief look at Earth, these are the volcanoes that are erupting. You got Sakurajima, you got Semaru continuing to explode. Merapi, Dacono, Popocatépetl. Not seen. Erupting San Chiquito, Fuego, Nevado de Ruiz, and Sabancaya. We are seeing an earthquake drought. So, forecasting earthquakes is a statistical analysis, as the real mechanism is not fully understood. So, pretty hard to forecast a thing when you don't have the variables, which is why everybody's models are garbage in, garbage out. But there's a forecast. You see that drought in 7 magnitude quakes? Earthquake droughts end in large earthquakes. And we've been having earthquakes up and down the North American Pacific Plate boundary. So take heed, those near the North American Pacific Plate boundary, as there have been ongoing quakes in the eastern Pacific Rim. As far as 5 and greater magnitude quakes in the past 24 hours, not too many of those. In fact, 0. Is it the calm before the earthquake storm, folks? Let us know what you think in the comments. I know you will. Anyway, next we'll show some stats. The 10.7 centimeter radial flux now at 170 solar flux units. 170 is the radial flux number. There's the 1-year graph. It's represented by the black line. The red line is the sunspot number. Space Weather Enthusiast Dashboard not forecasting any solar storms. We would tend to agree here are the past 4 hours of Earth's magnetic moment. From space. And Earth just moved into the South Pole magnetic sector just in the past couple of hours. In fact, it shows a signature in the solar wind, which we'll get to. A great example of a sector boundary crossing and a slightly different magnetic environment containing slightly different solar wind regime. Anyway, there is the ground magnetic perturbations map. And it's been a little bit of an increase in space weather as the South Pole current sheet features slightly stronger magnetic fields, again, which we will show you here momentarily. That's the past 4 hours of Earth's magnetic moment from the ground. Ground magnetic perturbations map. Next, our KP index is at 1.33. KP 1.33 is where it's at. And here's our real-time solar wind. Let's skip the ACE entirely because it looks garbagey. It's got a bunch of missing data, but the Discover right here, you see a sudden change. So the plasma is colder, also slower and less dense, but it features a stronger magnetic field. So that's a little uptick in Earth, in space weather activity at Earth, with a strong field there, much stronger field of 8 nanotesla with a BZ of -4. So that's much more conducive to electrical currents being induced in the Earth system and hence space weather occurring. So slight uptick here in the aurora tonight with the arrival of Earth into the South Pole-oriented magnetic sector, which we'll show you here right after the GOES magnetometer. There you go. There is our top view ecliptic plane field plot. And if you look at the last frame, Earth is on its last line there, which means it's already snapped across. You could clearly see the boundary crossing on the solar wind. Next, our line of sight field plot. A whole pile of data there in just a few seconds. That's 4 days worth of solar magnetism all at once. Here's our line of sight coronal hole plot. We already showed you coronal holes from SDO, so let's move right along to sunspots. Sunspot number here dropping down below 120. Sunspot number about 112 right now. And remember, folks, wild fluctuations happen all the time. As we get closer and closer to solar maximum, expect bigger and bigger waves of sunspot activity. In other words, higher highs and lots of big variations of few sunspots and huge numbers of 200 plus. Anyway, here is our synoptic map. Pretty unexciting actually at the moment, although keep in mind there is still a probability of X-class flares, especially on the western limb. So all of these groups here have become more likely to produce large solar flares. So all of those groups on that western limb. And there is a new active region rising up here behind the northeastern limb. So that's the other spot likely to produce large flares. We have seen some activity from 3584 and 3587. But those limb flares are the most likely ones, in my opinion. Continuing on to show sunspots. There is the SDO imagery. Another 24-hour video for you. And things have been somewhat stable there. Up some sunspots. Some new sunspots forming down here in the southeast. They're pretty minor so far, but besides that, a little bit of growth here as well. That is our, I don't know, is that the John Deere sunspot? I guess we shouldn't really name them. We name filaments after living people. So before we get to that, proton flux, X-ray flux, pretty chill. Not too exciting for the proton flux and X-ray flux. So proton flux returning to baseline levels, X-ray flux still in a C-class background range. No major flares in the past 24 hours. And here come the SDO data. Very nice. Very nice indeed. That's 94 plus 131 angstroms. And again, solar flare watch on the entire western limb there. And also up in the northeast. So right up here you'll see a brightening right in there. That is a new place to watch. There has been some significant activity going on up there. We think there is a new sunspot, a very large one, about to form. So could be interesting. And again, don't forget about sunspot 3576. Its likelihood to produce an X-class flare still remains, folks. So as we say on the channel all the time, we see flares from behind the limb all the time, and large ones. Before we get to CMEs, let's take a look at a star chart. Here's what's going on overhead for us. Lehigh Valley, Pennsylvania. Saturn is setting. We've also got Jupiter and a gibbous waxing moon up there. Here's your solar system forecast, courtesy of theplanetstoday.com. Here's where things will be in a week. Earth is getting even more lonely on this side of the solar system as there are 0 planets. Check it out, folks. 8 planets on one side, or 7 planets, I guess, and 1 planet on the other side. Next, the Bay of Naples. Yeah, the Bay of Naples. You got to have it. And how is that an astronomy photo of the day? Well, I'll show you. It's because of a meteor burning up over the Bay of Naples. Multiple chemical signatures there. There's the full image for you. apod.nasa.gov. Here come CMEs. I shouldn't say here they come because they're not on the way this way. That one out of the south is not earthly directed. So it might look like a partial halo. It's on the far side. So there are some more images. Some awesome, spectacular CMEs today that we covered while we did our live stream. We watched it evolve. I got to rant and watch it evolve all at once. So here you'll see it start to come out. It really took its time. It was a long duration CME. Look at how dense the plasma is. Very, very dense plasma there. And sometimes it does come out in a very filamentary fashion and not diffuse very much. So perhaps that tells us something about the magnetic fields. Look at that. Look at that dense stream of plasma coming out. That is nice. Very nice. Very nice. Let's also show stereo A. Not half bad. Dag. That is some burly stuff. Very nice. There you can see it is a little bit off to the west from the perspective of stereo A. So it's a clear indication that it is on the far side, not the Earth side. But once again, you can see that very dense plasma filament there, taking its good old time to get diffuse. It's not really getting diffuse. So that's a very, very dense bit of plasma there, really far outside of the obscurement disk. Let's take a look at our custom CMEs. Here's a sweet 24-hour video for you. Very nice. There's just nothing like syncing those images together like that, folks. It's so good. So good. And that's where it ends. Those are our custom videos. Let's get through our bonus features and get to meteorology. Filaments, filaments. Wherefore art thou, filaments? Because magnetic fields are suspending them above the sun's surface. So many of these are pointed right at you. So that's part of the reason why we name them. Lots of filaments on the Earth side of the solar disk. Here's the grayscale view, color view. And before we get to bonus features, the last couple of hours from the GO 16 SUVI. And let's do it. Bonus features. By the way, don't forget to visit our homepage, smashomash.com. There's all kinds of links. You can get involved, visit us on social media, support the channel, etc. All kinds of shopping. You can do some fantastic merch. If you didn't see today's 5,000 subscriber special, what the heck? What's up with that? How did you miss that? 5,000 subscriber special, a 5-hour-long live stream to celebrate 5,000 subs, thanks to our viewers, and 1 million views. Very nice, very nice. 5,000 subscribers. Cheers. We consider that a milestone. Charging hazards are next. We ain't got none. It's smooth sailing for satellites. The GOES electron flux here remains kind of low. Again, Earth is in a new magnetic sector. So South Pole sector now, having crossed the sector boundary crossing. Why did the proton cross the heliosphere? To get to the other sector, of course. Why did the planet cross the heliosphere? To get to the other magnetic sector. That's better. That's a little bit more of a common thing. Anyway, there's the 1-year graph of the electron flux. And here is the forecast model. Expecting a little uptick in the electron flux there. I would tend to agree with that. Next, the ionosphere. We'll show that layer. The F layer is what we're showing, the F layer, folks. Feel free to pause the video on this frame. It contains a ton of important information. Here's the F layer of the ionosphere. And just a little reminder, if you're viewing the videos on a mobile device, on the YouTube app, you can zoom in like 8 times. So it's quite useful. I mean, and the videos are pretty high res. So 19 something by 1280 or something like that. So anyway, that's the point. So yeah, ionosphere here showing lots of high frequency anomalies. You'll see a lot of blue on the map here. And yeah, space weather has been very calm, very calm. So some pretty big variations there actually in the northern hemisphere. Is it associated with stratospheric warming events? I don't know. Hey Eugene, have you seen this clip? Eugene, you don't answer your Discord calls. Have you seen this clip? Hope you're doing okay there, Chief. The magician from Minsk. It's Eugene the philosopher. Next, the Wham. It's not a careless whisper on your TV screen when the music dies. Look at the electron flux anomalies. Why are there such high electron contents at the northern polar region? Look, major electron anomalies up there at the northern polar region. See those? Major electron anomalies. Sound the alarms. Get in your bunkers. Yeah, so very high electron contents up there at the northern polar region. Does that have something to do with sudden stratospheric warming events? Hey, Eugene, did you watch this clip? Eugene's been studying sudden stratospheric warming events to try to figure out if the mechanism comes from below or from above. Anyway, we'll close out space weather with the latest high-res images, and those are frankly not that exciting, so not going to spend a lot of time on that. Let's move on to meteorology as my voice is giving out because I did a lot of ranting. So first, windy conditions, folks. Windy conditions indeed over the Great Lakes. Of course, bodies of water accelerate winds because the prevailing winds get to prevail. Since there's only one direction for them to go, land has a tendency to slow wind down because it's not as smooth as the water. Water has a tendency to speed winds up, and that's part of the reason why the Great Lakes cause lake effect snow on me today. Anyway, here are the planet's winds, surface winds of the east, and the jet streams. Jet streams of the central world, and the surface winds of the west, and the jets. Clouds and fog for the Americas. This cool low pressure in the northern Atlantic. Well off the coast of Newfoundland. It's making its way up toward Greenland, actually. It's making a turn to the north, folks. Next, snow cover for the U.S., and check it out. There's the aftermath. We got quite a bit here in Pennsylvania, like maybe 7-8 inches, I believe we got. It was very powdery light snow, the kind you can clean up with a broom, even though it's kind of deep. So it's going to get very cold tonight and then a little bit anomalously warm tomorrow. Next, our weather.gov map. Weather.gov. There are your warnings. So let's show the jet stream first. Here is that's not too bad. That's pretty good, in fact. The jet stream of the entire northern hemisphere there, courtesy of tropicaltidbits.com. So now I'm not seeing any major anomalies popping off there. Things are looking pretty normal in the jet stream there. And it's almost forming a hexagon. You see that, folks? Does that have to do with water? 1, 2, 3, 4, 5. Oh my God! It's not a hexagon. It's a pentagon, which of course you know contains a pentagram, and of course numbers are scary and spooky. So I apologize if I've scared and or spooked you with this segment. Next, pressure and precipitation for the lower 48. Heavy precipitation coming to California. Again and again, and again and again. Accumulated snow accumulated snow depth change in inches there, including some areas in California with over 3 feet of snow on the way. Over 3 feet of snow on the way. Total depth change in inches for snowfall GFS 72-hour model. 3 days, lots of snow coming. Next, accumulated precipitation. Look at some of the rains. 6+ inches in Northern California. Dag! It is becoming a very moist state. Also, Florida is going to get plastered with some heavy rains. North Central Florida, as well as California, plastered with precip. Last but not least, temperature anomaly in degrees Celsius for the same model, the 72-hour GFS. We got to close this thing out. Here's lightning. Here's real-time lightning map. Lake effect snow over the mid-Atlantic states. We'll show the full 50-state view. And then focus on the lower 48 view. Clouds and fog. And water vapor. Recap. And a tip of the cap. We are out. It's about that time. See you soon, and in the meantime, may that solar wind be at your back.